All right, guys. Are there any questions on any of the assignments thus far? Okay. Now, because what we did Friday was multiplication. Well, Thursday, Friday of last week was multiplication, multiplying two polynomial or rational expressions, where we had a over b times c over d, where b is not equal to 0 and d is not equal to 0. We get ac over bd. We multiply them together. And if there's something in common on top and bottom, we simplify it out.
Is there like a homework worksheet for 7.31?
Yes. Well, it's on the back.
Okay. Could I get the questions later?
Yes. What we're talking about today is division, dividing two rational expressions. And when we divide two rational expressions, we are going to be dividing but not dividing at the same time. Because when we divide two fractions, first we change it from division to multiplication and flip the second. We change it from division to multiplication and then flip the second term to get that there, and then simplify in any place that we need to. So we're going to look at this first one here, this first quotient, this first spot of division. And the first thing we can do is go on and change it. So our first term, our first rational expression doesn't change. So our 7 over 2x minus 10 stays the same. Now we change it from division to multiplication and flip the second. So now our second expression is going to be x squared minus 11x plus 30 over x squared minus 6x. Change it from division to multiplication and then flip the second. And we're used to doing this because we've done this with dividing fractions. It's not something new, but it is new applying it to these polynomial expressions. These rational expressions, really. Now, for the rest of this, it's going to be the exact same as Friday, because now we're just multiplying. So really, with the division, we change it from division to multiplication and flip the second. We're good? Now we need to factor each one of these here. 7x is already as simplified as it gets. Now 2x minus 10, x squared minus 11x plus 30, and x squared minus 6x. Which one of these do we want to factor first? 2x minus 10. Is there a greatest common factor? We can factor it out. 2 times, if we factor 2 out of 2x, we have x minus 5. Because we factor 2 out of 10, we're left with 5. Okay? Well, we can go on and do the x squared minus 6x, because x squared and 6x have a greatest common factor of x. So we factor an x out of x squared, we're left with x minus 6. So the last one we need to factor is the numerator, x squared minus 11x plus 30. So 2 sets of parentheses with 3 spaces. We can move on to that because there's not a greatest common factor. Since the 30 is positive, the signs are the same and they match the sign of the middle term, which is negative. So negative and negative. Our factors of x squared are x and x. Now we need to figure out what the factors of 30 are that we're going to use. We have 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, but 5 and 6 do? 5 and 6. And if we did check this here, x times negative 6 is negative 6x. Negative 5 times x is negative 5x, which does indeed give us a middle term of negative 11x. And as we saw the other day or Friday, really we can merge these together. If we want to rewrite it, we can. Let's scroll down just a little bit. So if I wanted to rewrite it as 7x times x minus 5 times x minus 6 over 2 times x minus 5 times x minus 6, I can. We can do that there. And at this point, we can simplify. Well, the x and x will simplify each other out. The x minus 5 will simplify out with the x minus 5. Bless you. And the x minus 6 and x minus 6 will cancel out, leaving us with 7/2. Mm-hmm. Now, before we move on, restrictions. I want to talk about restrictions with this division. Because again, we've talked about restrictions before with multiplication. Because it's whatever is going to make the denominator be 0, yes? Now, for us, I saw this here. You don't have to rewrite this back out, but I'm wanting to look at it here. Because this was our starting problem, yes? I already rewrote it back as factoring. So the denominators, we have 2. This here and this one here. So one of the terms is x cannot be 5. Because x minus 5, 5 minus 5 is 0. It doesn't work there. And we do have a repeated one here. X cannot be 6. Because it will make that be 0, yes? So we have those 2 terms. And that's easy to see. Now what happens if x is 0? Well, it'll make the numerator of the second one be 0, yes? Okay, that's not a big deal. Because if the numerator is 0, 7x over times x minus 5. If this is 0 over x minus 5 times x minus 6, what happens to this entire expression here? If the numerator is 0, the whole thing becomes 0, yes? So, if the numerator is 0, we can treat this as 0, yes? Now what are we doing? We are dividing by. So it works out for these here, when we look at restrictions, let me have a highlighter. We're not looking at just the denominators. We have to also look at the numerator of the second one because we're dividing by it. With division, we can't just look at the bottoms. We really have to look at the entire term that we're dividing by. This entire term here and the denominator of the first. So there's 3 spots we have to look at with division. For multiplication, we only have to look at 2. Does this make sense of how this works? Because since it's the first, if this is 0, we get 0 divided by our other term, whatever it is, which is just going to be 0. Yeah, 0 divided by something is 0. 0 over something is 0. That works. We can't divide by 0. Let's look at the next one. 11x over 3x minus 9 divided by x squared minus 5x over x squared minus 8x plus 15. And again, the first thing we can do is rewrite this. So 11x over 3x minus 9 times, and we flip the second one. So the second one's now going to be x squared minus 8x plus 15 over x squared minus 5x. Because when we divide two fractions, we change it from division to multiplication and flip the second. Now at this point here, we can do some factoring. So 11x is as simplified as it gets. It's one term. Not much we can do with it. What can we do with the 3x minus 9? Yeah, we can simplify it by factoring out the 3. Which one do we want to factor next? X squared minus 8x plus 15 or x squared minus 5x? So how can we factor it? Yeah, we can factor out an x, which leaves us with x minus 5. Because if we factor an x out of both terms, x squared becomes x, 5x becomes 5, which gives us x times x minus 5. Two sets of parentheses. X squared minus 8x plus 15. So since there's no greatest common factor, we'll have our two sets of parentheses. Since the 15 is positive, our signs are the same and they match the sign of the middle term, which would be negative and negative. And then we would have x and x and 5 and 3. And if we did go back and check it for the middle term, we would indeed get negative 8. Questions on this so far? Now at this point we can connect the lines because we're going to be simplifying. If you need to rewrite it, it helps you see what simplifies. Go on and rewrite it. Well, let's see what simplifies out. We have the x minus 3 and x minus 3. We have the x minus 5 and 5, and we also have x and, which leaves us with 11 over 3. They won't always work out this way. It's just that the first two that we have did work out this way. Now, if we listed the restrictions for the denominator of the first, well, we can't turn the 3, the greatest common factor 3, into 0. So we need to see what will make x minus 3 be 0. So if we set it equal to 0, we can add 3 to both sides, telling us x is 3. So if x is 3, that denominator would be 0, so we can't have x be 3. So if we look over here, we have two spots. We have an x by itself and x minus 5. Yes? The x, the greatest common factor of x, the one by itself, what value of x would make that be 0? Yeah. 0. It cannot be 5 either. Because for x minus 5, if we set it equal to 0 and solve, we would add 5 to both sides, telling us x is 5. And since it can't be 0, x cannot be 5. Now again, since we're talking about division, we also have to look at the numerator of the second, which was originally the denominator at the start of the problem, because we had to flip it. So we have to look at that as well. Well, x minus 5 is what? 5, and x minus 3 is, so we already have them all listed. So this here, if we were solving it, we cannot have x be 3, 0, or 5. Because if it's one of those three, it's an extraneous solution, and it doesn't work. Questions on this here? All right, we're going to find the quotient of this one next. So the first thing we can do is rewrite it and flip the second. Which will make x squared minus 6x plus 8 on top, and x squared minus 2x on bottom. Now 4x doesn't factor because it's a single term. Now 5x minus 20, we can factor out a 5, which leaves us with x minus 4. X squared minus 2x, we can factor out an x. Because if we factor an x out of x squared, we're left with a single x. And if we factor an x out of 2x, we're left with 2. Which leaves us with the last one here. X squared minus 6x plus 8. Since the third term's positive, our signs are the same and match the sign of the middle term, which will be negative and negative. The factors of x squared are x and x. And the factors of 8 that we want are 2 and 4. Now we can cancel out what's in common. X and x. X minus 2 and x minus 2, and x minus 4 and x minus 4, leaving us with 4/5. And here, what are our restrictions? X cannot be 2, 2, 4, and 0. Well, since we have x by itself, it's 0, because what's going to make the single x term be 0? 0. If we didn't have that, if this was, say, x plus 1 times x minus 2, then it wouldn't be there, because we don't have an x by itself. Yes, sir? If it asks for them, yes. If not, no. But it's a good thing to be paying attention to, especially when we start solving. Questions on any of these here so far? Because I don't think we have too many more of these. All right, let's do this one here. So we do have 2 rational expressions being divided. Now the first thing we can do is change it from division to multiplication and flip the second. Now looking at these 4 here, a minus 2, the numerator of the second. Is there a greatest common factor between a and 2? The degree of a minus 2 is 1, yes. Degree is the biggest exponent attached to the variable. So that is simplified. 2a minus 1 is our greatest common factor. What's the degree of it? 1. So that's as simplified as it gets. Okay, so now we got to look at the first one. Now the second one, we can go on and put parentheses around it because we do know we'll be multiplying. So we can include them there. Now the first top, 4a squared minus 1. So we do have a subtraction, so it could be a difference of perfect squares, since we only have 2 terms. Is 4a squared a perfect square? What times itself is 4a squared? Because 2a times 2a, 2 times 2 is 4, a times a is a squared, so that is a perfect square. How about 1? 1. So this here is a difference of perfect squares. So we'll have 2a plus 1 and 2a minus 1. A squared minus 4, is that a difference of perfect squares? It would be what? And And the order in which we place those doesn't really matter. We could have said a plus 2 times a minus 2, or a minus 2 times a plus 2. And at this point here, we're multiplying them together. So what simplifies? Well, a minus 2 and a minus 2. We also have into a minus 1, which leaves us with 2a plus 1 over plus 2. And that'd be the final answer. Now, if we wanted to look at restrictions, one of the ones we can look at is 2a minus 1. Now, we could set that equal to 0. I'll write it up here. 2a minus 1 is equal to 0. Well, the first thing we can do is add 1 to both sides, telling us 2a equals 1. Then we would divide by 2, telling us a is 1/2. So one of the values a cannot be is positive 1/2, because it would make this denominator here be 0. You know a can also not be 2. Because for our a minus 2 equals 0, we would add 2 to both sides, telling us a cannot be 2. And that would also work for the numerator of the second, because we have the a minus 2 over there. So a cannot be 2 for it, but we only have to list it once. And our last one is a plus 2 equals 0. So here we would subtract 2, telling us a cannot be negative 2. There can be more, they could be less. It just depends on what the denominators are, or what is going to cause us to have a division of 0. And out of those, the 2 in black are technically the ones, especially the book that we have, would suggest that we need. We wouldn't necessarily have to list the negative 2, because it's still considered a denominator in the final answer. Questions on this here? Are we good with these here? The next one, 43, isn't any real different than what we've had so far. And neither is 52 or 54. Really, the only difference in these is that we're throwing in sum and difference of perfect cubes, just different factors. It's not changing what we're doing. It's just utilizing other resources to do the same thing. This here is the last one I want to look at, because it does have a slight element that's different, but not by much. Because we looked at one of these on Friday, dealing with multiplication. The 3x squared plus 5x has a denominator of what? 1. It's not written, but it's understood that it's going to have 1 as a denominator. And that comes into play with division, because if we're going to find the quotient, we keep the first expression the same. We change it from division to multiplication and flip the second term. And that's the only real difference, because most of everything we've done today has almost been 100% like multiplication, except for the first main step. After we do the first main step, everything that precedes it, everything that follows it, is the exact same. Yes. The 4x squared is as simplified as it gets, because it's a monomial, one term. The 1 doesn't factor. So do we want to factor the 3x squared plus 5x first, or 6x squared plus x minus 15? Okay. 2 sets of parentheses with 3 spaces. The third term is negative 15. Since it's negative, our signs are opposite. One's going to be positive, one's going to be negative. Now we need to find the factors of 6x squared and the factors of 15. Well, for 6x squared, we know that we will have x and x. Now for 6, we have 1 and 6 or 2 and 3. 2 and 3. I'm just throwing 2, 3. Doesn't really matter. We'll need to check this one for sure because we do have a few more terms. 15. 1 and 15. 3 and 5. Which one do we want to try first? Three and 5. We'll put the 3 with the 2x and 5 with the 3x. Now, one reason we put it this way is because I can't put the 3 with the 3x. If we did, we would have a greatest common factor of 3, yes? Does 6x squared plus x minus 15 have a greatest common factor of 3? No, so there can't be 1 in either parentheses. Now, if we check this here, 2x times negative 5 is negative 10x. 3 times 3x is going to be plus 9x, which gives us a negative x. Is that what we wanted? We wanted it to be positive, which is an easy fix. We flip the signs to give us 2x minus 3 times 3x plus 5. And that would change it from negative x to positive x. So we have the correct middle term. Last part is factoring 3x squared plus 5x. It has a greatest common factor of, which leaves us with 3x plus 5. What are our common factors? And 3x plus 5. Is there anything else? No. So the numerator, we have 2x minus 3 times 1, which is, the denominator will have 4, what, x? Because we have x squared times x, gives us x to the third. If we are to list the restrictions, one of the restrictions would be 0, because the x squared and x that we have in the denominators, even though it's x squared, it's still 0. If we square 0, we still have 0. And the other one's going to be the 3x plus 5. We can subtract 5 from both sides, telling us that 3x is equal to negative 5. Divide by 3, telling us x is negative 5 thirds. So those would be our 2 restrictions there. And really, we would only have to list the negative 5 thirds because 0 is still contained in the answer. Questions on this here? Any questions over anything we've done so far today?
You don't do 2x minus 3 to give a restriction.
Well, let's see here. So that would be 3 halves, because we would add the 3 and divide by 2, yes? So 3 halves. I'm going to clear all this off and look at the beginning. So 6 times 3 halves squared plus 3 halves minus 15 over 4 times 3 halves squared divided by 3 times 3 halves squared plus 5 times 3 halves. So I'm just calculating this because it's going to make more sense plugging it in than trying to go through the explanation. So since these are all just numbers, we can calculate it out. So figure all this out. Yes. So 3 times 3 halves squared, I think it was minus plus 5 times 3 halves. Make sure it's 3. Yep. So this is the second part of the equation, what we're dividing by. 57/4 is what we have over here. On the first part, 4 times 3/2 squared. We'll just do the denominator. 4 times 3/2.
May I have your attention, please? May I have your attention, please? There is now sign up for the half.
So 9. So we have a denominator of 9 here. Now the top, we'll do it too. So 6 times 3/2 squared plus 3/2 minus 15. 0. So this here became 0, yes? Now, 0 divided by 9 is 0 divided by 9 is 0. Now we have 0 divided by 57/4. 0 divided by 57/4 is, so we do have a value, yes? Because we ended up with a value here. Now, what we said x could not be 0, yes?
So we already had it.
So 6 times 0 squared minus 0 minus 15. 4, 0 squared divided by 3 times 0 squared plus 5 times 0. So, right. So 4 times 0 squared is, this whole thing becomes, now the numerator, that's 0, but we have negative 15. Now what is negative 15 divided by 0?
Right? Oh.
Error.
What? It's really complicated.
Now, division is essentially glorified subtraction. So if we said 10 divided by 2, we know what 10 divided by 2 is, yes? It is 5. So if I subtract 2 from 10, I get, so that's 1. If I do it again, 6. 2 times 4, 2. How many times did we do it? 10 divided by 2 is 5. It's just glorified subtraction. That's what division is. It's saying how many groups of 2 can we take out of 10? 5. Now, let's do the same thing with this here. We'll ignore the negative for now. So 15 divided by 0. So what's 15 minus 0? Okay? Because we're trying to do the same thing. 15 minus 0 is? Because there's no way we can actually get how many groups would make it become 0, as we did with 2. So is there any way to divide by 0? No.
Okay. Yep.
There's another way to look at this. Is essentially we're saying 15 divided by 0 is x, yes? Or we're saying what times 0 gives us 15? Well, anything times 0 is? So is there any way to multiply a number by 0 and get? No. This is why we can't divide by 0. This is why it doesn't work. But that is all we're doing for today.